So we talked about OR inequalities, how they have a tendency to graph apart, how you'll do them or solve them separately. This is basically the opposite of that. So and inequalities have a tendency to graph together. And I'll show you what that means here in a second. All the internet wants to go on spring break too. Okay, so if we have these two at the end, we could graph them like normal, graph them as is. So we have a closed circle at -6 that would be going to the right. We have a closed circle at 1 going to the left. And we are looking for where those two overlap. So that would be starting at -6 and ending at 1. So once we start this, we'll really just be focusing on the red. We won't have to graph the other two. You can still graph the other two, but we're just looking for the and, where they overlap. So then our interval notation would start at -6, it's closed, so square bracket, and it ends at 1, square bracket. But then we also rewrite it. So when we have and inequalities, because they fall between two endpoints, we write this in a more condensed way. So I'm going to rewrite this down here. And instead of writing x is greater than or equal to -6 and x is less than or equal to -1, we can write it in set notation, starting with -6 is less than or equal to x, which is less than or equal to 1. So we've seen that before when we've done domain, and that's basically what it was. Between two numbers, from this number to this number and everything in between. So when we write our answers, they'll need to be in this format. So we'll do a couple of these and then move on to the next, unless you want to see another before we move on to the next. So start with this first one. When you solve these, you do everything to everything. So if I'm trying to get x by itself, I have to get rid of this 4, so I'm going to subtract it everywhere. From the middle to the outside, on both sides, because I'm trying to get rid of it. So then everything should change when you do that. The middle, there should be no more 4. The outside numbers should change because you subtracted 4. And then we can graph this. -2 would be closed. 5 would be open, and we would draw a line connecting them. If you want to still see the overlap, you can still draw the others. Don't have to do this part, but you can. This part you would read as is, the second half, you would read as is, x is less than 5. So open circle to the left. The other part, though, you have to read backwards. So start here and go backwards. X is greater than or equal to, because the way it's pointing is away from the x, -2. And you'd be able to see that overlap. Again, don't have to do that part. As long as you know where they overlap, the red lines, you're good. How would we write this interval notation? Where would it start? -2, bracket or parentheses? And then where would it end? 5, bracket or parentheses. Remember, it can be mixed. Questions on that? And let's do the last one on this page. Let's do this one instead. 9 instead of 10. So then we would need to still get rid of the 1, so subtract 1 to all sides. How would I get rid of the 2/3? Okay, so we could multiply both sides by 3 and then divide by 2, or we could do that at the same time. Multiply by the reciprocal to everything. So this would become just -3 is less than x is less than or equal to, this would become 12 over 2, so 6. If you had something in the middle that when you multiplied or divided, you multiplied or divided by a negative, your signs would change. So let's say this was 2/3 x instead. If I had to change them, and I'm making this up so you don't have to write this down, but you can. If I had to multiply by a negative, everything would change directions. But you would still have to write it least to greatest, and the signs need to be less than or equal to, so you would flip the whole thing around. If that were the case. Again, I just made that up. So -3 would be open, 6 would be closed, line between them. I'm not going to draw the overlap, but you are more than welcome to. How would we write our interval notation? Are there any other problems on this that we want to see before we do the next piece? Or any questions that we have? Go on to the next page. So what's nice about absolute value inequalities is that we basically already know how to solve them because we've solved absolute value equations and we did compound inequalities, and it's like a combination of those two. But let's talk about these cases first. So when you have greater than or equal to, you are going to graph what you have. So x is greater than or equal to 5, but you're also going to have the opposite. X is less than or equal to, you're going to change it and change your sign. So at 5 greater than or equal to, going to the right. At -5 close, going to the left, flow. So when we have greater than or equal to absolute value inequalities, they will become OR inequalities, where they will graph apart. What's also nice about absolute value is that the signs will be the same, so they'll either both be brackets or both be parentheses. So this would start at negative infinity, go to -5, be a bracket, or start at 5, bracket, go to infinity. And then you can probably guess what happens with the other one. It's the opposite. So here, do what it says. X is less than or equal to 8. But then also take it, flip it, change the sign. So greater than or equal to -8. So then this becomes an and because they overlap. So then our interval notation starts at -8, bracket, ends at 8, bracket. Now the numbers may not always be the same, and it depends on the word. But the cases will always be the same. Greater than or equal to will always give you, or unless you're dividing by a negative, then it changes. And then less than or equal to will always be and, unless you divide by a negative, because then the case changes. Questions so far? I'm going to have you fill this in after you finish writing this down, and then we'll go through a few examples. So absolute value inequalities are really compound inequalities, so that's good because we just talked about those. Less than equals and, greater than equals or. And then the steps: isolate the absolute value expression just like absolute value equations. Create two cases, just as we did before. Usually there's a negative and a positive version, but with our negative version, we have to change the direction of the sign and change the negative sign. Solve both inequalities and then graph. So we're going to do 3 or 4, 7 or 8, and then 9 or 10. And then be done for today. I'll let you guys choose. Anyone? we're skipping over 1 and 2 because that's really what we just did in the example. So between 3 and 4, which would you rather see? 4. Okay. So from our examples, this is a less than or equal to. So this should be an and. Sometimes that changes, but it's good to kind of keep that in mind. That way you know kind of what it's going to look like. The absolute value expression is already isolated. There's nothing on the outside. So here's where we create the two cases. Drop your absolute value sign. Keep one exactly the same. Then for your other case, keep the inside the same. Inside is always the same. Change the direction of the sign. Make the number negative. Solve both. If x is less than or equal to 5, and x is greater than or equal to negative 9. So if this is an and, they should overlap, but let's just make sure. So greater than or equal to negative 9. Start at 9 and keep going to the right. Less than or equal to 5 would start at 5 and keep going to the left. So they do overlap. It is an and. So after that, I'm going to do two things. Rewrite this as a condensed. Negative 9 less than or equal to x less than or equal to 5. And write the interval notation. They would both be brackets. So you don't have to know that less than will create an and, but it is good to know. Whether you do all three or just the and is up to you. You may want to see which one it does, just in case you've forgotten which type it is. What questions do we have on that? And then between 7 and 8, which of those would you rather see? Okay. So right now, this is a less than, so it should be an and, but it may change because it's negative. So I'll put and after. So for isolating, we have to get rid of the negative 2. How would we do that? Multiply by negative 2 on both sides. Remember that when we're multiplying or dividing by a negative, the sign is going to change. So now it is a greater than, which has now changed to an or. The absolute value is now isolated, so we can make our two cases. 4x minus 8 is greater than or equal to 12. Is it the same? The other one, the inside the same, 4x minus 8, is now less than or equal to negative 12. And then we can solve both. Add 8. Divide both by 4. So this one gives us x is greater than or equal to 5. This one gives us x is less than or equal to negative 1. So I could draw those. X is less than or equal to -1, close to the left. X is greater than 5, close to the right. It is the or, like it said. So this starts at -infinity, it goes to -1, square bracket, or starts at 5, goes to infinity. I would also rewrite this on the document. Questions on that one? So had we not done absolute value equations and knew that there were two cases, and not done compound inequalities and solved these type of cases, this would be harder. And then between 9 and 10, which of those do you want to see do? We'll go over. 10 has the most amount of stuff. So if you could do that one, you could really do all of these, just making sure you graph correctly. Right, so we have to isolate first. What would be our first step? Yes. We have 1/2 absolute value 4x minus 4 is less than or equal to 4. Still have to isolate. What would be our next step? Jaden. Take the reciprocal 1/2, 2/1, or just 2, multiply that on both sides. Absolute value is now isolated. We have a less than, so this should be an and. And then we can graph both. Or, I'm sorry, set up our two cases first, then solve and graph both. So 4x minus 4 less than or equal to 8 is 1. 4x minus 4 greater than or equal to -8 is the other. Start to solve. Add 4 to both sides. So 4x is less than or equal to 12. 4x is greater than or equal to -4. Divide both sides by 4. So then my condensed will be -1 less than or equal to x less than or equal to 3. And whether you want to draw the overlap or just draw this part is up to you. And then these would both be brackets. Do we have any questions about this? I'm going to show you two things on Khan Academy. The compound inequalities, just because it may be a little weird. So on this blank sheet of paper on your next practice page, write these down, and then you will be free to do work. sometimes these are straightforward, sometimes they're not, and you kind of have to think about them a little weird. Okay, so when it gives it to you, the and or the or, they will be separated already, so you will solve both of them separately. A little bit more. I'll also rewrite these just in case you can't see them. So negative 7x minus 50 is less than or equal to negative 1. Write that one down. And negative 6x plus 70 is greater than negative 2. I'm going to write that above here. Drawing number lines for these are going to be your friend. It's going to help you a lot to be able to visualize. So, solving this one, we would add 50. Divide both sides by negative 7. Sign would change. And then for your other one, subtract 70. Divide both sides by negative 6. Sign again changes. What is that? Okay. So it has to overlap where x is between negative 7 and 12. So you could draw the number line, but it should be D. I'm going to skip a bunch of numbers. I'm not writing every single number between negative 7 and 12. So it would be greater than or equal to negative 7 going that way, right, and less than 12. So where they overlap would be so the and is still where they overlap, but draw a picture because sometimes they overlap everywhere, and that could be like infinity, all real solutions. Sometimes they don't overlap anywhere, and that would be no solution, and you just have to play around with it, see where they overlap. Okay, and then let's do one more. So 2x plus 3 is greater than or equal to 7. Or 2x plus 9 is greater than 11. Solve both of them. So this one we're subtracting 3. And then dividing. And then this one we're subtracting 9 and dividing. Where on our notes and our practice, we want these to go like this, be on opposite sides. Khan Academy is looking for everything, where everything is true for the ors. So still do the number line because it might help. Alright, so we have 1 and 2. Open here and close here. So starting where, or to make everything, or both of these true, it would be that x is greater than 1. Not really where they overlap, but from start to finish. What are you looking at? I was getting confused on this.
Oh, no, you're right. Sorry. I was confused.
No, you see I got one wrong already, so I had to go back and fix that one. But, no, sometimes I doubt myself, so it's okay. I was like, did I choose the wrong one? Okay, but look at it like from start to finish, your answer. And that should help, but draw the number lines also. Okay. So you guys can be working on Khan Academy, SOL, other school stuff. You can have your own, all of those. Let me know if you have questions. Yes.